The next question of CC starters 110 is Tetris.
In this question, there are two people. One is chef, other one is chefina. Right? They are actually playing a game in which they are supposed to clear Tetris. Right? The each player can either clear one Tetris layer or two Tetris layers, three layers, or four layers.
Yeah.
Right? Basically, the game starts by chef. Chef starts playing the game, and whenever there is a turn where chef is playing or chefina is playing,
Yeah.
if the person clears one line of Tetris or one layer of Tetris, then the next person plays the game.
Yeah.
Right? Otherwise, if the person playing the game clears 2 lines, 3 lines, or 4 lines, then the same person continues.
Yeah.
Right? That is the question regarding how they play the game. And the game stops when together chef and chefina clears at least L lines of Tetris.
Yeah.
Right? If at least L layers of Tetris are cleared by chef and chefina together, then we stop the game.
Yeah.
Now, chef wants to end the game in style. Basically, he wants to end the game. And when he's ending the game, he wants to make sure that he clears 4 layers of Tetris.
Yeah.
Right? And our job here is to figure out how many sequence of moves are there in which this is possible, where chef is ending the game, and while ending the game, he is performing 4 moves. Like basically, in the single move, is clearing 4 levels of Tetris.
Yeah.
That is the question. And as these sequences can be very large, we need to print those number of sequences modulo with 10 power 9 plus 7.
Yeah.
Right. Looking at the constraint of the question, it is given that there are 3 test cases where each test case is in the range of 1 to 10 power 5. And we have L given, which is the total number of levels that they will clear together. And this is also in the range of 1 to 10 power 5.
Yeah. So in this question, the prerequisite is dynamic programming. So this don't involve too advanced dynamic programming, but at least basic DP should be known to solve this problem. Now let us see how we can solve this. Let us first define our DP. DP of I of who. Let's say. So who is something which is of two values, 0 or 1, and I will range from 0 to L. Let's say for now it's 0 to L inclusive. So this tells us that both the players played in turns. How many ways? First, in how many ways both the players played in turns with the current player as current player as 2. Remove I Tetris. So now, so basically this is defined as follows: in how many ways both the players played in turns with the current player as 2. Removed I Tetris. So in how many ways I Tetris were removed and the current player's turn is 2. Now let's define what is DP of I of 0. dp of I of 0 is in how many ways both the players played optimally in turns with the current player as check. So here the current player is check if it's dp I of 0 and both of them removed I together in turns, and dp of I of 1 means the current player is checking and both of them removed I Tetris. So this is the dp. Now let's see how we can make transitions. Now we have four choices. Okay. One choice is they can remove one Tetris. When they remove one Tetris, their turn will flip. Now they can remove two Tetrises, three Tetrises, and four Tetrises. In the case of two Tetrises, turn will remain the same. Here also turn remains the same and turn remains the same. Right? Now based on these, let's make the transition. Now let us calculate dp of I of 0 and dp of I of 1, assuming that we already computed the values of dp of j of 0, dp of j of 1, where j ranges from 0 till I, till less than I. So, assuming this is what we already computed. Now, firstly, let's make check turns transitions. This is when this is if the current turn needs to be checked. So if current turn needs to be checked turn, then in how many ways can we reach this turn? Check turn. So now if I want dp of I of 0, that is removing I Tetrises and the current turn to be checked turn. Firstly, if previously it was checked turn, yeah, when it was I minus 2 and if it was checked turn, then he could have just removed two blocks and still it would be checked turn. Right? Similarly, I minus 3, this means from this state, he removed three Tetrises and it became I. And the turn did flip. Now, one more scenario is removing four Tetrises. Even in this scenario, checks turn won't change. Now, the last scenario is removing one Tetris. In this case, uh, if we already removed I minus 1 and if it is check turn, then we can't reach I of 0 right? Because turn will flip. So it should be check minus turn. So this is how we can calculate. And perform modulo. So I did perform modulo on this. So perform modulo ensuring that it won't exceed the required range in your manual. Basically, the answer should be in the range 0 to mod minus. Ensure that. And now for Chefina, let's make it transition. Chefina. 1. It is just similar to checks. So if she removes two blocks, then uh, this is how she can reach IN 1. And similarly, if she removes three blocks from this state, that is dp of I minus 3, then she can reach dp of I of 1 state. Similarly, removing four blocks. Okay. Now removing one block. If she removes one block, then previously played move, if one block is removed, then previously played move should be checked. Then only current turn will flip to check. So this is how we can calculate. Here also perform mod. This is how we can compute the values for every thing. And here the base condition is dp of 0. That means will be 1. That means uh, there is one way to reach a state where zero number of Tetrises were removed and the current turn is checked, because that is the starting state. So this is one. This is the base condition. Now let us look over one thing. Now we handle the situations where players will play in turns and remove the required option Tetrises. That is 1 or 2 or 3 or 4. But one more case isn't handled. We want to find out the number of ways such that the both of them will play in turns, and the last performed move is Chef's move, and after Chef's move is performed at the last, then at least L Tetrises will be removed, and the last move performed by Chef is removing 4 Tetris moves. So for that, what we can do is, and one more thing, here when we are performing I minus 2, I minus 3, I minus 4, I minus 4, ensure that this I minus 2, I minus 3, I minus 4, those won't go negative. So write if statements based on the case word. Now answer for any L would be any L. Let's say it would be dp of L minus 4 of 0. This tells us that both of the players played in turns and removed L minus 4 Tetrises, and they should remove 4 more Tetrises. I mean, then check should remove 4 more Tetrises such that number of removed Tetrises will be at least 2. So removing L minus 4 Tetrises, and currently it's check's turn. So for sure, because this is the last move that check is gonna perform, he'll for sure perform. We are assuming that he's performing a move where he should remove 4 Tetrises. Then only it's called he finished in stride. So in this state he'll remove 4 Tetrises plus. In this state he'll remove 4 Tetrises, because here it is at least L Tetrises. They didn't mention we should exactly remove it. Tetrises are infinite, we can assume. And first point, when at least L are removed, the game terminates. And the last move performed should be checks, and he should be performing. He should be removing 4 Tetrises first. 0 plus dp of L minus 1 of 0. Okay? In all these scenarios, Chef will perform a last move where he'll be removing 4 hits. And we shouldn't have dp of L of 0. That is because dp of L of 0 tells us that both the players played in turns, and they removed at least L Tetris. They removed exactly L Tetris, and it's Chef's turn currently. That's what it tells us. But we don't know whether previously Chefina played and it became Chef's turn, or whether Chef played but he played a move which is removing which is removing 2 or 3 Tetrises. So because of that, this shouldn't be added. So we add these up, and in this scenario we'll assume L minus 4 Tetrises are already removed by both the players playing in turn. And in the current Chef's turn, he'll remove 4 Tetrises and finish the game. Here L minus 3 are done, and he'll remove 4 Tetrises and finish the game. Here L minus 2 are done, remove 4 Tetrises, finish the game. L minus 1 are done, remove 4 Tetrises, finish the game. So this way we can answer for every test case. But now the issue is, for every test case we can't create a DP, as our DP can be of size L of 2, right? And this L can be 10 power 5. So here test cases are 10 power 5. and L is 10 per 10. Okay? So P into L would be 10 per 10, which is not sufficient for 1 second. Now, one observation that we can make is if we calculate dp values till 10 power 5 of 2, all these values, then all the lower values of this can be used for lower ends. Right? So that is why we need not recompute for every end. What we can do is, before the test cases, find out the answer for every one, L is equal to 1, L is equal to 2, so on till L is equal to 10 per 10. As L can be at max 10 per 10, and even L is equal to 0. However, L0 isn't given, but that is a base condition. So all these answers are already computed. So we can compute these answers in 10 power 5, 2 into 10 power 5 time compute. Okay? So once we compute this, we can just answer every query in O1. Right? This will be the answer for every test. So this way we can solve the problem by just recomputing it. So time complexity for this would be big of 10 power 5. Let's say it is 2 into 10 power 5 for pre-computing plus test cases. As per test case, we just answer it one and ensure that we perform modulo with mod for this value, ensuring the value will be in the range 0 to mod max. So this will be the time complexity, and space complexity would be big of 2 into 10 power. So this way we can solve the problem.